Thank you for showing up to my talk, From Doctor to Coder, A Whole New World. My name is Aisha, and I am a double doctor. That's to say, I have an MD and a PhD, and I hail from the wondrous world of medical academia. But I am also a co-organizer of the cross-language user group DOMcode, which is based in Utrecht, not far from here. And over the last few years, I've gotten more and more involved in the tech community, organizing events, making new friends, making new connections, and kind of figuring out for myself, like, hey, I'm kind of missing that aspect in my own professional career, like having something to do with tech. So last year, I decided to switch it up. I quit my job in medical academia, and I became an information analyst at Uniqueness, which is the Dutch Expertise Center for Healthcare and IT. And I made a new career goal for myself. I wanted to bridge the translational gap between the medical and the technical worlds. Yes, I put a lot of thought in this before I put it on my LinkedIn profile. And today, I want to take you through my journey going from medical academia into this more tech-rich environment and tell you of the more interesting sights that I saw along the way. Starting with, changing careers, because that's what I did. I wanted to, remember, translational gap, bridge that, all that, between the medical and technical worlds. And I figured medical world kind of had that covered, MD, PhD, it's kind of good. But the technical part of things, I kind of quickly discovered I was much like Jon Snow. I know nothing. And I wanted to understand the mindset of the developer to be able to make that translation. So I figured the only way to do that was to learn how to code. And thankfully, to my relief, I was not the only person to ever have made this kind of career switch. Because I asked around on Twitter last year, and there were quite a few people saying like, oh yeah, I switched out from being a ballerina or a musician, an electrician, a meteorologist, Arabic linguist, English teacher, you name it, it was there. And people had two main reasons for switching. Like, some of them were already coding as a hobby, and it was a hobby that kind of took over their professional careers. Other people were saying, well, their previous career choices did not pan out the way they wanted it to, and tech opened up new opportunities for them. So, real quick, who of you have made such a career switch yourselves? All right, keep your hands up real quick and let everyone take a look around. Because I think it's very important to know whether people that you work with or are friends with in the tech world have made a switch like this before. Because it's very different switching into tech from a different field, from learning tech from the get-go. Switching to this, because we are actively stepping out of our comfort zones to make the switch into tech. And that can be a pretty terrifying thing, because we may have, in our previous careers, built ourselves up to be an expert in that field, in that subject, and then suddenly be downgraded back to newbie level. And that can be a very big hit to our self-confidence. Like, think about imposter syndrome, a much talked about topic in the tech community. Think about how it feels to you having experience in software development, and then think about how it feels to us making this switch very new. So I want to take you through some of the differences that I found, speaking from my reference frame in medical academia, and compared to what I found was more common in this world of tech. The first thing being, to me, a pretty obvious one, but maybe not to you. The high versus low barrier of entry. So the requirements before you start a professional career in one of these fields. Because in tech, I kind of found out that self-teaching was very much an accepted way of getting started. You can teach yourself the basics of code and then learn the rest on the go, on the job. You can go the formal route if you want to, get an education, get your degree, but it's not necessary always. Whereas in medicine and academia, there's a certain papers, please mindset. You have to go the formal route. There is no alternative route. And that ties together with all of the knowledge within these fields being kept very closed within, like only available to a small group of experts. And that has to do kind of with the fact, I think, that there is a certain publish or perish mindset among academics. In order to make a career in academia, you have to publish your research results in the most, fanciest of medical journals, or the ones that have the highest impact factor, and preferably one buzzword as a title, like science or nature. And these journals are, held by publishers that are going to ask for really high subscription fees for people to actually be able to read them. So there's a literal paywall between the knowledge within those fields and like the general public, which I think is wrong. So there are initiatives to break through that, and my favorite is Sci-Hub, which maybe you've heard about. It's basically the Pirate Bay of academia. Like, there's over 62 million articles in their archives right now that they kind of plucked from behind the paywall and made accessible, free to read for everyone who wants to take a look. And that's awesome in my eyes, but not exactly the most legal way of going about things. So researchers can also opt for so-called open access publishing. And that's, as the title says, it means you're publishing your articles so that anyone can read it. There's no paywall. The problem with this is that researchers actually have to pay 2,000 to 3,000 euros for publishing an individual article this way. And that's on top of the subscription fees that their research institutes are usually already paying to the same publishers holding those journals. And that's pretty ridiculous if you think about it. And like, it's gotten a little better in the last few years. Like, big research institutes have gotten negotiations done with big publishers to get rid of the double charge. So now their researchers that already have the subscriptions can publish open access without the additional fee. But it only counts for new articles coming out, and there's still a whole bunch of older articles still behind that same paywall that people just cannot get to. Now imagine for you, if you had to pay a couple thousand euros license fee for every single open source repo that you are using in your day-to-day life right now, and how quickly that's gonna add up. All right, so next I want to talk about how we treat failure. Because failure is not really an option in medicine and academia. In medicine, like if you're a surgeon, you can't say like, oh, I have heard about this new surgical procedure recently. I'm gonna try it out on this patient that's ready here to go on, And if you're working in academia, those same publishers that want to publish your research results, they're not going to be wanting to do that if your research shows that that fancy new treatment you came up with has no effect whatsoever. So failure not really an option in these fields. Whereas in tech, at least I found that failure became much more of an opportunity to learn, because failure is sort of an inherent part of tech learning. You're going to write code, and it's going to break, and it's not going to run, and you're going to have to figure out what's going on and fix it, and then hopefully you'll be good to go. So having this be something that is accepted and normal was a huge game changer for me, who was not used to that at all. All right, so for all the differences that I've just discussed, there's also a bunch of similarities between our worlds that I've discovered. And especially thinking that we've built up skills and expertise in our previous careers that may not be directly applicable to tech, but may sort of still be sideways transferable anyway. And the biggest one, I think, is that we are all problem solvers. We have people who come to us with a problem, and they expect us to use our knowledge and our expertise to come up with the best solution for them. Now, doctors have patients who come to them, patients have symptoms, doctors are supposed to diagnose them and prescribe them with a treatment. And maybe you're thinking, yeah, I'm a developer though, I work with computers, not people. That's not entirely true. You've got clients. Clients come to you with a problem. They expect you to come up with a software solution. So it's very much the same thing. And with this mutual skill that we have, we also come across a mutual challenge, namely expectation management. Because these people do not come to you only with a problem to solve, but also with preconceived notion of how that problem should be solved, or how it should look like at least. And that expectation may not entirely line up with what you, with your expertise, think is the ideal situation, a solution. So it's up to you to talk to these people, figure out what is that they're expecting, and then try and correct any unrealistic expectations that they have in there, which is an art and a skill all on its own. All right, so for all the differences in learning that we have, we also do something quite the same in education, because we all learn by doing. So you can't read a book and perform surgery the next day. You also can't read the book and write up the next Facebook in one day. You have to learn by doing. You have to practice. You have to do, simulations and code katas and all that stuff. And once we start learning, we also can't stop, because there's so many new developments and new knowledge coming out of these fields that we have to keep up. And if we don't, we run the very real risk of our carefully built up knowledge and expertise becoming obsolete very, very quickly. And just to illustrate this, do not try to read all the stuff on the slide. But this is all the developments in the last few decades in medical genetics and the World Wide Web. And this part is only that part is the last 25 years, but that much has been happening. This much we've been having to keep up with in our professional lives. And, there is a genuine information overload in our fields. The British Medical Journal published back in 2009, so it's probably even worse now. But they published then that at the time there were over 25,000 scientific journals for science, tech, medicine put together. And in one single year, these journals published over 1.5 million new articles. So there's no way that one single person is going to be able to keep up with all of that new information all on their own. So we need to find ways to cope with this information overload. And one way that I found in medicine is standards. So you might think standards, okay, that's more for interoperability, like making different systems be able to talk to each other. And yeah, that's very much true. But I also think that standards are meant for sharing new knowledge. Because a standard involves an expert group getting together, diving into a particular subject, and getting all that new information, stacked together, and weighing all the information against each other, and then writing it down in a more easily digestible format that an individual doctor or individual developer can then read, and use in their daily practice. So I think it's important to think that standards are not just meant for interoperability or pushing certain visions on other people, but also to share new knowledge and help the individual person to keep up with the latest best practices. Two more things that I want to share in terms of that we have similar, but slightly in a different field. High pressure jobs. We all have high pressure jobs. We are all too familiar with deadlines, working overtime, being on call during evenings and weekends, and generally struggling with work-life balance. And this high pressure can have devastating consequences. Because in the Netherlands, 1 in 5 medical students and 1 in 8 medical residents experience burnout. Now, I tried to look up these numbers for the tech industry, but all I could find was a slew of articles that was asking things like, usually after how much time do software developers, experience burnout? And there were answers in there that were kind of like, I usually experience burnout 2 to 3 times a year, ranging from 2 weeks to 90 days. And the fact that burnout is considered usual in the tech industry tells me enough that this is a huge problem here as well. The last similarity, diversity. You may think that diversity is not an issue in medicine and academia because we fixed the pipeline issue. In the Netherlands, back in the 50s to 70s, about 20% of medical students were women. In the 2000s, that risen to an undeniable majority of like 67%. But when you look at the higher management levels, that is reduced to like 4 to 16%. So there's still something going wrong there. And the numbers don't get much better if you look at academia in general. Because, over the last years, we do see a rise of women in universities in all different levels, from PhD all the way to full professors. But if you look at higher up the rank ladder, you see that gender gap just growing bigger and bigger and bigger. And if we keep going at the current steady growth rate of 0.8% per year, so not even 1%, it's going to be 2055 before we get an equal ratio of men and women professors. So I'm 32 years old right now. I'm going to be older than 70 by the time that rolls around. So I'm going to retire before we get to see an even number of men and women professors. And that's just kind of ridiculous. So what I want to tell you with this, by drawing these parallels, and this is just gender, this is not even covering ethnicity or socioeconomic status or all the other aspects of diversity. But I want to share with you, this is not just a pipeline issue. And I want to ask you to open your mind to the possibility of there being other aspects at play here that need to be, evaluated, reassessed, and possibly adjusted to get to a higher diversity number. All right. So, what makes tech education so unique, and what are those things that you as a tech community ought to cherish and uphold, because it's those things that make you so special? Well, I've already kind of mentioned it, but low-cost learning, the fact that it's so easy to find low-cost or even free books, courses, workshops, websites to learn how to code, that is really awesome. And not just that, but there's also active communities around all these different technologies that help people to get started. There's people who are actively, offering to mentor and coach newbie people like me. And even if you don't consider yourself a mentor or a coach, you are still very valuable as a peer. Because when I'm writing code and it doesn't want to compile and I'm ready to throw my laptop out of that window, all I need is for one of you to look over my shoulder and say something like, I've had that same problem. Yeah, just Google for it. You're going to find an answer on Stack Overflow and implement that. You'll be golden. That's how we all do it. So all we need is someone to tell us that this is normal. Frustration is part of the normal learning process. And that's what helps us stay motivated to keep going. The other thing I love about tech runs through all things, just like the Force. So we probably have other hobbies and interests before we get started on tech, and probably have come across some kind of problem or frustration within that hobby that might actually be possible to solve with tech. So it's possible to say oh, hey, I've got, this thing that I've got an existing passion for, and then use that to grow your newfound passion for tech. And that, I think, is really, really awesome about tech, to be able to do that, to fix all the things. Something that I hear a lot of people say, when I started to learn to code, I suddenly could do everything. And that idea is it's very empowering. All right, so not everything is shiny and bright and rosy colored in terms of tech learning. I do see some areas for possible improvement. For me, the very first problem I stumbled upon when I wanted to learn how to code was analysis paralysis. Because there are so many different computer languages out there, how was I supposed to pick the one that I wanted to learn? And think back to yourself. What was the very first language you learned? Why was that? And would you recommend that to someone like me who's starting out new? And even when you've picked out a certain language to learn, the question becomes, how are you going to learn it? Because again, there are so many books and websites and everything out there to learn, it's kind of difficult to figure out what's the best fit for you. And there's this Code Pancake. It's a learning platform for coding, pretty awesome, run by Lieke Boon, who put together this list of different resources to learn how to code. And ranging from really general websites like Codecademy, Coursera, that offer a range of different computer languages, to Python-specific or Git-specific stuff. And this is not even a full comprehensive list, and that's pretty hard to get together. And this already does help to know, get a start of what's out there. But at the same time, it can be kind of overwhelming. Okay, I want to learn something, but there's this many places. Where do I start? So if you want to help us newbies get started, what I think would really help us is if you could build us a resource that tells us, okay, if you have this kind of learning goal, then you want to look at these different languages, and these are the best ways to go and learn them. Because I think that would help us really get our feet wet in tech without getting overwhelmed by all of different possibilities. All right. So another thing I think tech learning would benefit from is to make reflection an inherent part of it. Again, we learn by doing, and we can only learn by actually pausing to reflect on what we're doing to do better next time. And you may think, okay, but we already have code reviews and sprint retrospectives, so we are already reflecting on a lot of things there. But those are usually very much aimed at code, which is good because that's your main core business. But there's also a lot of other issues that I've already spoken about today, the high pressure jobs, the expectation management of your clients, all that sort of stuff that may be worth reflecting upon if that's something you've experienced and have need some feedback on. And in medicine, reflection is a very iterative part of practicing using a structure called intervision. And there are many different ways to do intervision, but they all sort of revolve around this Kolb cycle of experiential learning. And you basically get together a group of peers. It's important that they're all peers because you don't want someone in the group to have power over other people in the group, because you want a safe environment where everyone can share their experiences and thoughts without fear of retribution. And one of the people in this group has a concrete experience that they want to reflect upon. So they tell the rest of the group, okay, what is it that happened and what were the results of that happening? And then the group helps this person to create these abstract concepts of like, what did the results imply and what did this person do to influence those results? And then the group also helps to think of alternative actions that this person could have taken to possibly lead to a more beneficial outcome. So this person can then figure out, okay, what am I going to do next time? What other action will I do if I have this same situation in the future? And then actually do it. And this, I think, is the most beautiful thing about this whole cycle, because you come to a concrete plan of action that you can implement right, the very first time that you have the same situation in the future. So even if you can't implement this in like existing team meetings or anything, maybe if you have something to reflect upon yourself, you can still benefit from going through these 4 steps, so you at least come to a new plan of action for the next time you have the same situation. All right, so things that I learned in tech that I kind of wish I hadn't. Because it's kind of like finding out that astronauts use duct tape to fix like everything from lunar riders to oxygen modules, and it works. They come home safely for the most part, so it stays together, but you really can't help but wondering why it's not just falling apart at the seams. So there's 4 of these concepts that I want to share with you, how I experienced them as I was learning about that being the case. First off, floating point imprecision. So I was a researcher in my previous life. I did a lot of statistics because I had to prove that all those research results I was finding were not pure coincidence. But I'm really bad at math. So I was really happy that there's these statistical software packages where I could just enter my data and hit a few buttons and a number would roll out, and a number tells me, yeah, that's significant, so put that in a paper and awesome. But then I found out about floating point imprecision, and I started thinking to myself, wait, I thought computers were good at calculating. But if I, as a human being, am more capable of saying, okay, 1 divided by 10 is 0.1, period, but a computer's going to tell me, no, that's 0.1000769, whatever. And I know that calculations can depend on very, very, very tiny fractions. Let's just say that my faith in computer-generated numbers has been terribly shaken, and I've never been quite the same. Time zone management. Now, I know times and dates are a nightmare to work with for devs in general. However, time zones are their own special thing, because turns out it's just a list of time zones that is managed by a handful of volunteers who are in no way associated with any governmental bodies who actually regulate these different time zones. And so there's this thing on their website to help update the list that says, if your government plans to change its time zone boundaries or daylight saving rules, let the mailing list know well in advance. So I don't know about you all, but I'm really bad with daylight saving, so I tend to wake up the next morning and think, oh, it's that late already. So to think that this entire management system is reliant on people like you and me who happen to think on time to send a ping to this mailing list like, hey y'all, there's this change coming up, FYI. Might want to put that in your list, make sure that it's updated. I don't know how this hasn't been breaking all over the place. DNS poisoning, another fun one. I knew how DNS lookup procedures worked. I just didn't know that until very recently, there were no verification steps involved whatsoever. So if someone wanted to like redirect entire masses of people from what they thought they were going to, the website that they entered the URL of, and redirect them to somewhere entirely else, there wasn't that much to keep them from doing that. And it has already kind of happened on a large scale before, because the Great Firewall of China is based on DNS blocking. And in 2010, a Swedish ISP accidentally configured our DNS servers to point towards DNS servers in China. And so suddenly people all over the world were unable to reach Google and Twitter and Facebook, and panic broke out. And that got fixed on time, and now we have DNSSEC, and DNSSEC is supposed to fix everything. And then I hear, well, DNSSEC is also not entirely foolproof. And I mean, just the fact that it took this long to fix this very essential part of the web at all, like decades, I don't know. It boggles my mind. Lastly, frameworks. I know this is a sensitive issue in the tech community, so I'm not going to go into too much of that controversial stuff. I just want to share with you how it came across to me. Because as I said before, my goal was to learn about the abstract concepts that underlie software development and understand the mindset of people that work in this. So I decided, okay, I'm going to do a computer science course by one that was offered by Harvard on edX.org. And it was going to teach me those abstract concepts by coding in C. I was like, okay, sure, C, whatever. And then I went to do a Ruby on Rails workshop. And it was like magic, because all I had to do was copy-paste these lines from the tutorial into my command prompt and hit enter. And my terminal would start scrolling and scrolling and scrolling with lines and lines and lines of something happening. And I had no idea what. But then suddenly I had a website that had a pretty blue background, and you could upload kitty pictures, and people could put comments on there, and you could upload more kitty pictures, and I mean, it was awesome. Like within the span of a few hours, I had a very, fully functioning website live where people could just do all this stuff. But I had no idea what was going on under the hood. And I started thinking to myself, okay, if I just put this website live without any idea of what's going on, then how are professional framework developers doing all this? And now I know, okay, most websites don't need a customized approach, and you don't want to reinvent the wheel over and over and over for very basic functions like, user login or picture uploads. So it's a really good thing that frameworks are out there to, take care of that. But considering that I wanted to understand all the stuff that was going on underneath, I'm just going to stick to my coding by hand, okay? Okay. So my experiences learning in tech kind of boil down to this quote by Peter York. Nobody knows anything. I deal with people in all walks of life, some of whom should have some idea of what they're doing. And they're all clueless. It's astonishing that any bridges stay up, or that planes don't constantly plummet from the sky. It's heartening in a strange way. So, I want to end with 2 take-home messages. You can forget everything else I said, just remember these 2 things. We are all Jon Snow in some things, but Yoda in other things. So when I started out, I knew nothing about tech. And you may not know as much about medicine, but we both know our own things, and we do have things in common. We are all problem solvers. So remember what you do know and equalize those levels of respect between us, because we need that to work together. And take nothing for granted. That includes the learning environment you find yourselves in, as well as the reference frames you've built up for yourself over your years of experience in software development. Because there's so many of these abstract concepts that are second nature to you that are just entirely mind-boggling to someone like me who's just learning. And at least I'm part of the group who is learning, who is trying to make these concepts our own. But you're going to deal with a lot of people who are not going to learn, who shouldn't have to learn. Think of your clients, think of your users. And they are not going to understand why you're so frustrated when they throw yet another feature request at you, unless you help them understand. Help build these bridges. So, quick thanks to all these awesome people. And if you want to contact me, find me here or any of these online ventures. And thank you for your attention. And if there's time, then I'd be happy to answer any questions. Questions, anyone? Oh, yeah, I'm not going to be able to reach back there. I think there was a question there.
How does it work? You hear me?
Yes.
Yeah. Hi, thanks for the talk. Yeah, so we're trying to organize some beginner courses here, on volunteer basis for people to learn coding, actually.
Awesome.
So yeah, I had very similar problems to what you said. So without doing it on purpose, I forget, as a developer for many years, some basic stuff, how I learned them, because I learned them so far back that I don't remember what it took.
Yeah.
So do you have any tips, like how to, I mean, apart from the fact of realizing it, how can, for instance, explain what a variable is if you have only 5 hours to try to explain the basics of programming? I find that very challenging.
That's a good question. I actually, I mean, for me, it's different. Like, first year, I've not been in this long enough to think of, oh, I'm going to explain it this way to someone new. But maybe it would help to sort of test run it with a couple of actual newbies who then, can actually go over things like, hey, this is how you explain it, but I don't follow. Or could you explain this and this a little more concretely or something? And maybe use a lot of practical examples. Make it as practical as possible that takes away the abstract part of it. Because I think that programming and anything to do with computers kind of have, it looks like math. Oh my God! So if you take away that sort of fear out of it and make it as practical as possible, then maybe that helps. I'm not sure how you could do that, but
Thanks.
You're welcome.
Hi.
Hi.
Do you ever regret making the transition from the medical world to IT?
Not at all. But I've had different reasons for stepping out of patient care even before I started research. I genuinely felt like I wanted to do more with really that bit between medical and technical, because I see a lot of stuff in medicine that could benefit from tech, and nobody in medicine really understood what was going on with tech. So I just got frustrated with nothing happening, or at least not enough happening, I felt, on that field. So now I feel like I can kind of make a difference on that. And yeah, I'm just happier working on that than dealing with patients every day. I mean, I do kind of miss patient contact, but I'm very happy where I am now. So.
That's good.
Hi.
Hi.
Hello?
Yeah, I hear you.
It was just a comment. I think you forgot to mention something that's similar between medicine and tech, which is that every time your friends have a problem, at any time.
Can you fix my printer?
Yeah, they would call you to fix it for free.
What's this weird spot on my skin? I don't want to know. I don't want to go to the GP. Can you tell me what it is? Yeah, this is a very good point. I will definitely add that.
That's it.
Oh, there's a question over there.
Let me try.
Ah.
Hi.
Hi.
You talk about a close community of academia. So do you think it should be changed or how it's going on? It should be like more open source, like programming industry? But do you see any developments today about academia, that there is some like Sci-Hub that is demonstrated, but they are like kind of pirate examples, I
Yeah,
say. But
exactly.
From internalized actions from academia, do we see any of it?
There are some, there's some push for this. Like I said, the open access publishing is a big thing that people are trying to be a standard way to publish. There's also a lot of push to share actual database, so actual research data, to share that openly, because that's also not been a big thing before. So there's definitely more push for that, but it's still a very slow-going development, especially because if you want to publish your results, you have to be the first one to have those results. So if you share those results with other people, then you run the risk, at least that's how people perceive it, you run the risk of those other people, taking your results and going to publish it and beating you to the punch. And then your own professional career is at stake. And I think people have to kind of let go of that mindset and to get to this more open and collaborative environment where I think we should be heading towards. And there's, like I said, there are people who are getting towards there, but it's a very slow-going process. Anyone else? Don't think so. All right. Well, thank you everyone for your attention, and enjoy the break until the closing keynote.